Hello dear friends, welcome to this video. In this video, we'll be looking at the question how to find out the reflection by the line or the plane passing through origin. Right, so the question is asked that how you can find out the orthogonal transformation that represents the reflection. Now here it could be R2, it could be R3, it could be R4. For any kind of a plane Rn, the answer is given in general. If I have Rn, if I have a plane passing through origin, the transformation that represents reflection by the plane P which is passing through origin is given by, that would be a transformation from Rn to Rn. That means whatever you give input, the output is nothing but its reflection by the plane. And this transformation is given by T of x bar. Your input is same as x bar minus 2 times x bar u cap in a product and then multiplied with u cap. Now the question that would be there in the student's mind, that what is this u cap, right? This u cap. What is this u cap? This is nothing but a unit normal to your plane P which is passing through origin. Right? So if you can find out a normal vector to that plane, convert it to a unit vector, use this transformation, you get your required answer. Right? So by using this result in our hand, we can prove what is asked or we can find what is asked. But I request student to think how this result must have derived. Right? But we here, since we are just asked to find out the orthogonal transformation, I come to the question. I need to find out the orthogonal transformation in Rn with respect to the reflection by the given plane. For an example, for n equal to 2, they are giving me x equal to y. So if I try to observe this is my x and y axis. This is my line x equal to y, right? So this is going to be my required answer is nothing but a transformation which sends 1 comma 0 to, it should send it to 0 comma 1, right? It should reflect every point by that line. I want to find out that transformation. What I have learned, that transformation, required transformation would be from R2 to R2 given by what? Given by T of x comma y, since I am in R2, is same as x comma y minus 2 times inner product of xy with the unit vector and multiplied with the unit vector. What is that unit vector? Unit vector is nothing but orthogonal, yani ki perpendicular normal, right? So I need to find out this vector now. So given a line, I need to find out a normal to it. First of all, I can write my x equal to y as my x minus y equal to 0. As students are learn in their SY, I can write this is same as f of x comma y equal to x minus y, and that is given to be equal to 0. So my function is defined like this. How to find out normal to the line? The normal to the line is nothing but the gradient. Gradient of f is nothing but partially differentiating with respect to x comma partially differentiating with respect to y. So my gradient of f is nothing but partially differentiating this with respect to x is 1, partially differentiating this with respect to y is nothing but minus 2. So what I got? I got the normal to the line. This is normal to line x equal to y. But do I want only normal? No, I want the unit normal. So what I do? I just convert this to a unit vector. So my required u cap is nothing but 1 by root 2 comma 1 by root 2. But it is minus, right? Why I divided by root 2? Because root 2 is nothing but norm of this vector u. Suppose this is u bar, right? U bar is nothing but the normal to it. And this came out to be root 2. Which I found like 1 square plus minus 1 square. So now I know what is my u cap. So I just write it over here. right? My u cap is nothing but 1 by root 2 comma minus 1 by root 2, and it is multiplied with 1 by root 2 comma 1 by root 2, but it is in minus. So what I get at the end is nothing but, so this is equal to x comma y minus 2 times, what is the inner product? Inner product is x by root 2 minus y by root 2. Whole thing is multiplied with 1 by root 2 comma minus 1 by root 2. So if I just do this simplification, it is x comma y minus 2 times, this is nothing but x minus y by root 2. What I see inside this, I can take root 2 common. So root 2 inside the bracket, something left is nothing but 1 minus 1. So this 2 root 2 get cancelled. Ultimately, I have x comma y minus x minus y times 1 minus 1. So this is nothing but x comma y minus x minus y and y minus x. I just distributed that inside. And if I do the coordinate y subtraction, what I observe, it is nothing but y comma x. Therefore, my required transformation is actually nothing but, for the first one, the required reflection is nothing but x comma y getting mapped to y comma x. And I think this is something that you expected as well. If I have the line x equal to y, and if I do the reflection, the coordinate will get swapped. For an example, the way 1 comma 0 becomes 0 comma 1. Right? Similarly, if I have a point over here, that will come over here. So I gave you a general idea by using which you can find out a reflection by the plane passing through origin, whatever be the dimension. Right? So what I request student is, just let me know the answer for this two question. Over here, I think it is x. Okay, over here it is x. Just let me know the answer of this two question in the comment section, so I can know that you understood the concept, and as well as other people also can verify their answers. What is the step? You need to use this formula, right? What is the formula that we have noted as a result? That the reflection is given by the transformation Tx bar is same as x bar minus 2x bar u bar inner product u cap unit product with u cap. What is this u cap? It is nothing but unit normal to whatever it's there. If it is a line, it is a plane, it is totally fine. Right? Fundamentally, we call it as a locus. Right? I should have used the word locus, not the plane. I could have used the word locus, that is more precise. Okay. So now we come to a higher dimension. If my n equal to 3, that means now we are working on the plane. My locus is nothing but the plane. I want to find out a reflection which is represented by this. So the first thing is, I write my f of x, y, z. What is my locus? Locus is nothing but collection of all those points where my this x minus y plus z is equal to 0. So what is my gradient of f? That will work as my u bar. I'm interested in u cap. This is nothing but 1 comma minus 1 comma 1. What is this is nothing but the normal vector. I want a unit normal. So I should divide everyone by what? By their norm. What is the norm of u bar? Norm of u bar is nothing but root 3. So my unit vector is nothing but 1 by root 3. So I just write it like this. This is much easy, I think. Writing that root 3 times, I just write it at 1 minus 1 1, and the whole thing is divided by root 3, where this is actually nothing but the norm of u bar. Right? So now I know my required transformation T is from R3 through R3 defined as my T of, since it is R3 to R3, it is x, y, z, get mapped to the input as it is minus 2 times inner product of input with the unit vector that we find, that is nothing but 1 minus 1 1, whole thing divided by root 3, and this inner product, whatever is that scalar number, I just multiplied with that unit vector, that is 1 minus 1 1, whole thing divided by root 3. right? So ultimately what I get, it is nothing but x, y, z minus, I can take this root 3 outside and this root 3 also. So I get 2 by 3. What is inner product of this with this? That is nothing but x minus y plus z. Okay. And that has to be multiplied with 1, minus 1 and 1. Is it okay? Is it going fine? Okay, let's go further. So this is nothing but x comma y comma z. I just distribute that inside. So it is minus. This should get with everybody. So it is nothing but 2 by 3 x minus y plus z. Okay. And then minus. So it is minus x minus y plus z whole is multiplied by 2 by 3. Comma x minus y plus z and the whole is multiplied by 2 by 3. Now I need to find out subtraction of this two. So it is nothing but x minus this. X minus 2 by 3 x minus y plus z comma y plus 2 by 3 x minus y plus z comma z minus 2 by 3 x minus y plus z. So after this also there is one more step in which you can simplify it further. But what you can see over here, you can see this represents me my required reflection by the plane x minus y plus z equal to 0. Right? Similarly, you can try this one and let me know what is your required reflection transformation by this plane in R3. Right? Let me know the answer in the comment section. If you understood what need to be done, please share it with your friend, like and subscribe to the channel. Okay? Bye bye.